mean, it sounds
Right.
cool, but like not argue.
Find me the inverse from yesterday. Not prove it, just find it. Okay? Remember, there's a difference. So just find me the inverse. Talk to me. What's the first thing that we got to do?
You gotta switch the MX to a Y.
We got to switch the mx to a y. Or the m of x to a y.
And then you.
Hold on, give somebody else a chance.
Just trying to get my points in that I know.
I know. Then what do?
Emily's got this.
What do you got? Switch the x and the y. Switch the positions of any x's. Any x's become y's.
Oh, okay.
Any y's become x's.
Yes, sir. Louis got this next one.
Louis, what do you got for me?
I don't know. Like divide by, no.
No.
Take the 84 and move it to the other side.
So what are you basically doing in through all of that?
Solving for y.
Solving for y. Yep, exactly. Solving for y. So we would take the 84. We would move the 84 to the other side by adding it.
See, you got that. Ryan's
Oh, yeah.
next. Yeah, well,
Hey, he's answered his question.
I answered the easiest thing.
Uh-huh. Brian, he's calling you out.
Divide the equation with 17.
Love it.
At least I'm calling on the foot.
What's 84 divided by 4?
I don't think it is. Is it? Yeah, then no. So no.
I didn't bother. I was like, yeah,
Mhm.
I think it's okay.
Mm-hmm. Then what?
Cube root of 5. I didn't even.
So fifth root it?
Yeah.
Yep, fifth root, both sides.
Cube root. And like close enough. We get the idea. I think it's just.
So that becomes then the fifth root of the fraction x plus 84 divided by 17. And then very last thing, what are we going to do? We flip the y back to, in this case, so it'd be m negative 1 of x. So inverse of m. Love it.
Easy.
What's up?
This is like cool and all, but like, when would you ever use inverses?
I'm going to tell you in the next slide.
All right.
Yep.
Really, you keep front. I'm surprised I didn't ask that about.
Okay. So I want to play. We played this game once before. Okay. I want to play the game function, not a function. Okay. There's one rule that we've got so far in function, not a function. Anybody remember what it is? Or one test, if you will.
Oh, is it for like one and one thing?
No.
Vertical line.
What the vertical line test? What does the vertical line test tell us?
Oh, that's
Put a
cool.
line in there, and then if it crosses more than once,
You lose if your graph touches your vertical line more than once, right? Okay, I love it. So that is going to be used. The vertical line is going to be used to determine if what you're looking at is or isn't a function. Okay? So is or isn't a function. So for instance, if we had that, drop a little vertical line action on that. Actually, I should go a different color. Too much red. A little purple. So that one's only ever touching one spot. All the way through, right?
Oh,
So that's a function, right?
yeah.
Passes my vertical line test. Love it. Okay. Rule number 2. Now we're going to add in rule number 2. Now I'm going to take that vertical line
You flip it sideways.
and I'm going to flip it on its side.
Oh,
So what's that now? It's going to be the horizontal line test. Now the horizontal line test is going to be used to tell me if the inverse of what we're looking at is or isn't a function. Oh, let's see. I need a color. Need a color.
Honestly.
Yeah, I can't use yellow. Doesn't show up very well. Yeah? So there's our horizontal line. If we slide it up, in this case, still good, still good, still good, ruh-roh. Not good, right? Okay. So this one, in this particular function, it is a function, right? But the inverse is not a function. Okay? Out there in the world, there are these special kind of functions where they are functions and their inverses are functions. Okay? And those special kind of functions are called one-to-one functions. Okay? Now, where you're going to use this in the near future is I've seen your final. There is a one-to-one question on your final. So in the near future, that's where you're going to go for. Right now, it's the internet is busy searching for jobs that use inverse functions.
Upside down. They deal with everything inverse. They start from the end and work to the start. Terrible job, okay.
Yep. All right, so I'm going to show you a couple of different graphs, and then we're going to answer these 4 questions for each one. Okay? Now, do you have to be accurate in your sketches? Well, yes and no, because of that. Because now we're talking horizontal line test, so we can't just say, okay, this one's got a big old hump. You know what I mean? We got to kind of be a little bit accurate with it. Maybe throw in a couple of points. I'm not saying you got to throw in every single point, 0 to or -10 to +10, but throw in a couple. Figure it out. Okay? What is this graph going to look like? 2x squared. Close. Because an exponential just grows in one direction.
Just grows in both directions.
So what do we call those?
Quadratic.
So what do we call those quadratic graphs? It's a P word. Parabolas. Yep. This one's going to be a parabola. Okay? So it's going to look like that. Right? Yeah. Handle it. My first question is, what we are looking at, the red function up there, the first question asks, well, actually the first question asks sketch. The second question asks, is it a function?
Yes.
Why?
Because as long as you have vertical line.
Mm-hmm. Like this black one right here?
Yeah, that's iconic.
Okay.
You could just run it across double spots.
And that's going to continue. That pattern's going to continue on up and up and up and up forever. Yep. Yep. So f of x is a function.
I'm just about to say.
Actually, you had the second. Third one is the inverse of function. William, why not? Right there. It's 2 points. So the inverse is not a function. So is this a one-to-one function? No, because they both have to be yes in order for it to be. Okay. X to the third minus 2. What do you think it's going to look like? Yeah. It's gonna. So let's work left to right. Okay. So left side of the graph, is it going to be up high or is it going to be down low? Well, so let's put a negative number in there, right?
Yeah.
Negative times a negative times a negative.
It's a negative. It's a third power. Yeah, that's right.
So it's down low, right? Okay. Then as it gets closer and closer to 0, it's going to curve. It's going to rise up to -2, right? Because at 0, it's going to be at -2. Okay. And then what's going to happen?
Was like up and then up again.
And then it goes, and it keeps going up, right? Okay, because it's a cubic, so a positive number, positive times positive times positive is a positive.
Yeah.
Right? So it's going to look like that. Okay? So my question is this. What we're looking at, function, not a function. Function, inverse function, not a function. So it is, the inverse is a function also? Okay, let's just check it here using our horizontal line. Scanning, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Looks like 1. Yep. Okay. So that means it's 1 to 1. Okay, how do we find the inverse?
I don't think it's a lot anymore.
Well, how do we find the inverse? F of x is x cubed minus 2. First thing we do, y. Switch. How am I going to do that? Add 2. Cube root both sides. So the inverse of f is the cube root of x plus 2. And this function is 1 to 1.
I have to prove it for 2.
Didn't say that.
That's for checking.
You know what I mean? Didn't say that. It just said that we had to find it.
Yeah, maybe instructions really.
Huh? Love it? You try that
Actually,
one. Right. So what does this graph look like? It's a V, right? Opening up or opening down? Up. Yep. Love it. Maybe I don't love it. Now I love it. Okay? Is it a function?
yes.
Is the inverse
No.
a function? So it's not 1 to 1, so we don't have to find the inverse. Okay? Now, so far, we've done a function that didn't have its inverse as a function. We've done a function that's inverse was a function. Then we did that one, which is the same one. What if I was able to, or we are able to, what if we had this?
That it wouldn't be a function, but the inverse would.
Exactly. Okay. Okay. So we can also have relation. That would become a relation then because it's not a function. Okay. So this relation is not a function, but the inverse is a function. Okay? And we'll do more of those after spring break when we're dealing with ellipses and hyperbolas.
Should I come back and look there a sling or a crutch?
Yeah. Yeah. Again, I remind you that some of you are missing a lot of things. Okay? Please utilize this time that we have off in the next, 12 days to better yourself and get your stuff in. Okay? I am done for the day today.